So your initial setup should look something like this. Future value is 2 million. Our current value or present value is 10,000. We got 1 plus R. Now this is an annual rate, so the N is just 1. So we can just not even include the N there, just make it R. And then to the NT, N is 1 again. The time is 55 years. That's from when he's 10 till when he retires at age 65. He'll have 55 years for this to get interest. So pretty long time. And then we need to solve for R. So this ends up working similar to what we're doing yesterday, except once we get the parentheses by itself, it looks a little different. The first step is the same as yesterday, and I think we got this right. Yeah, right around 10%. So on that. First thing we're going to do is divide both sides by our 10,000. When you divide with big numbers, a little shortcut you can do is just cross out the zeros. So you actually end up just 200 divided by 1 is just 200. So 200 equals 1 plus R to the 55th power. So someone had figured it out. What do you do for this step? Yeah. Yeah, exactly, yeah. We did this one thing last week with the doubling and tripling. You take the 55th root on both sides. Oops. And if you don't remember how to do that, you do 55, and then you got to have math x root. So you're going to do 55 x root, and the math thing. And then you do your amount, which is 200. This is in the math screen. And that will give you your 1, gives you 1.1011. Equals 1 plus R. And then we just subtract 1. So minus 1. R is then 0.1011. And so our last step then is to make this decimal a percent. Go over 2 places and we get 10.1%. So while that's high, it's definitely not impossible to find that. Something 10%. So if you got extra 10,000 laying around, idea to invest it. Does anybody have like a grandparent or anything that put money aside for them with their?
We discussed my grandparents got to. So, Grandma, when you die, are you gonna give me your inheritance, or?
Well, no, like so. My great grandma, she put. I forget how much it was. I think it was like a couple thousand, just for like all of her great grandkids and like their inheritance. So when we turned, I think it's when we turned 18, or was there 18 or 21 we got $7,000. It was nice. It was a nice gesture.
Grandkids, great grandkids, and great great grandkids. My grandparents have like over 30 grandchildren.
Yeah.
So I think if anything, we're just gonna get the random junk that my
Right.
grandma hoards in her basement. I don't really think that we're gonna get money.
Yeah.
That's what is this thing gonna do?
No, she just has random stuff that she's gotten at like yard sales in Goodwill over her 80 years of life.
Maybe you can make it your goal to pass on some money to your grandkids someday. You got some extra money. It is a kind of a neat thing to do. Not all my grandparents have done that, but so one of my great grandmas did that. That was nice. Kind of keeps your memory, I guess, around. It was interesting too, since I brought up video games. I looked up the top grossing video games, and Pokemon was like blowing the other ones out of the water. It grossed $90 billion, and Mario pales in comparison to like 30 something. So, that's crazy. Yeah. Then you got Call of Duty. It's a relative newcomer compared to the other ones. And the Wii, I like the Wii, Wii Sports and all that stuff. And then you got Pac-Man. Pokemon. Yeah. crushes the competition. Never got into Pokemon, but one interesting thing that I saw actually in the news today, if you followed any of like the inflation stuff, so today they just had the consumer price index report came out, and we hit like the highest inflation in over 40 years, since 1981, since before I was born. So you can see if you don't have your money invested and it's not getting any interest, you're basically like losing money, right? Because the prices are going up 8.5% and you're not getting anything on your money, you're basically losing money. So if you're getting 8% out of your investment, then you're basically breaking even now. You're just not getting or losing money. Yeah, it's up 8.5%. You can read all kinds of articles on it, but that takes into account like grocery prices, gasoline, all that stuff. So it's gone up a ton. As you guys don't buy as much stuff, but you probably noticed most of the gas pump. So
Gas went back down. Like Ed Sheets was like 3.
yeah, it has gone down some, thankfully, in this area. Overall, I think it's still going up, but pretty much everything is costing more. Rent is more. This one. I think I saw like meats up like 13-16%. Of course, gas being higher means everything is higher. So that also means that the Fed can raise rates too, which means it costs more to get a loan for a house, things like that. So not good. Hopefully, it levels out at some point.
I think the price of beef was like $1.50 last year for a pound, like for a whole cow to sell at a slaughterhouse.
Uh-huh.
And then the bones and everything was twice so cheap as regular buy at the store.
Mhm.
And last I heard it was like $2.70.
Yeah, that's crazy. Yeah, we get a my brother-in-law. He raises cows, so we get like a half cow for you. It's a little bit cheaper. But yeah, it's crazy to buy any sort of meat, chicken, beef, pork. Pork's super expensive right too. And the thing is, salaries haven't risen to like meet that either, right? So like it costs the average family several extra $100 a month. Anyhow, today we're going to finish our last thing, which is solving for the rates like we did in that Walmart problem. Tomorrow will then be a review over like all of the compound interest stuff we've done, and then Thursday we'll have our quiz/test, whatever you want to call it, quest, all that. So this will be our last thing here for our quest. Quest sounds more fun too.
Yeah, but seriously.
Huh?
It's misleading.
Yeah.
Yes.
I prefer to call them quests. One of the quest. All right, so this problem here, Paisley is going to invest $28,000 and leaving an account for 14 years. Assuming it's compounded monthly, what interest rates will be required in order for Paisley to end up with $74,000? So a good scenario to go with this problem would be a lot of people when they retire, sometimes they'll take out like a lump sum of money and pay off something. So like let's say this person has a mortgage, and when they retire in 14 years, they're going to want to pay off their house so that they don't have to worry about a monthly mortgage payment. And in those 14 years, they're going to have this $74,000 left on their home mortgage, so they want to pay it off. And they've got some money saved already, and they want to make sure that when they retire in 14 years that they can just pay off the rest of the house. They don't have to worry about the mortgage payment. It's a pretty common thing. So they got their $28,000 that they've saved in their maybe in their retirement, and they wanted to make sure it's $74,000 so that they can pull that out and pay off the house. So what interest rate are they going to be looking for in order to achieve that goal? We're going to just start similar with our last one. Our future value of $74,000. We've got our present value of $28,000. Then we've got our 1 plus. The only difference on this one is we're going to have a rate over This one is monthly, so we're gonna have a 12 underneath for that rate. And then we got times our NT up here, so it's gonna be 12 times 14 years. It's gonna be the same steps, except we're gonna have an extra one to go here. We're gonna start by dividing both sides, so we're gonna make sure I get this R by itself. We're gonna divide both sides by 20,000. You're gonna be doing this on Delta math, where you have to make sure you put it in rounded correctly. So don't like simplify anything until the end, other than like what you can do is cross out zeros, and that won't change the value. So I would do that, so you don't have to carry everything. And then just keep this as 74 over 28. Don't worry about simplifying it yet. Don't make it a decimal yet. Leave it like that. Equals our 1 plus r over 12. And then 12 times 14. And then that's 12 table to memorize. Well, it's not that hard if you do 12 times 12. Everybody knows that, right? 144, and you just add 12 two more times.
Well,
Huh? Can you do 12s?
I could have do 12s in like elementary school. I used to know them.
Well.
I learned my 12s in like 7th grade.
36, 48, 60, 72, 84, 44. Alright, so when we get to this point, we're going to take the 168th root of both sides.
168th root?
Yeah. Yeah, it seems kind of crazy, right? 168th root, but it does make sense. We got 168th power, so we need to do the opposite of that. And 168th roots. Just make sure when you do this, you are going to do your 168. You're going to do x root. Put it in parentheses with your fraction here. It's a fraction. It may still work without the parentheses, but anytime you're going to do a fraction, it's good. Alright, so I got 1.0058 and some more stuff. I'm going to keep that on my calculator though. I'm left with just 1 plus or 12. Just keep it on there. We want to then move the 1 or the 12 first. Yeah, we'll just subtract the 1 first. The opposite of order of operations. When we do that, it's just going to cancel out the 1 here, so we're left with 0.0058 equals r over 12. And then we just multiply both sides with 12. So just take it on your calculator. What you had before, do minus 1, enter, times 12, enter. And don't clear your calculator, just leave it there. 0.06961. The one thing that might trip you is the rounding here. This is our rate as a decimal. We need to make this a percent first. So move it 2 places to make it a percent. 6.91, that's 6.961. And then we need to round this to the nearest tenth. So the 10% is going to be looking at this 9 here. It's a 6 next to it, so that rounds up. This will actually round to 7.0%. 7%. So you got to move the decimal 2 places. When you get your answer, move it 2 places, 6.9%, and then you got to round from that to the nearest tenth of a percent. So don't round it before you move it. Move it and then round it. Let's try one more like this. Robert's going to invest $640, leave it in there for 20 years. He wants to have $1,280 after that 20 years. Seems kind of like a low amount, but what he wants. So future value is $1,280. Current value is $640. 1 plus. Our rate we don't know, that's what we're trying to find is the rates. And this is compounded quarterly. That's 4 then. 3, 4 times 20. That's 80, so it's got 90. So first step is to divide. What's that? Goes at 640. And you get this canceled to 0, but then leave the rest of the stuff there. So cancel out the 0, and leave you with 128 over 64. We got 1 plus r over 4, the 80th power. Once we get the parentheses, then we're going to take the 80th root. Both sides. Alright, so typing that in, we're going to do 80, x root, parentheses, 128 over 64. We get 1.0087, 1 plus r of 4. And then it's just going to be subtracting 1, so then you just take that and do minus 1, enter, and then times it by 4, times 4, enter. R is 0.0348. Now we move it 2 places, and actually I made one more decimal for this one. So we move it 2 places, 3.480%, and it's rounded to the nearest hundredth of a percent. So this is the tenths, this is the hundredths. So we round it, look next door, it's 0, so we just keep it as 3.48. Just watch the rounding. I think if you like 99 chances on Delta Math, so you could try it as many times as you need to. All right, last one. I just want to show you one with continuous compounding, but it's actually easier. All right, Emma's going to invest her money here, $5,300, in an account for 19 years. Assuming the interest is compounded continuously, what interest rate is going to be required to end up with $7,700? 19 years. So the main difference here is we're going to use our compound interest, or continuous interest, which is our A equals PERT, P-E-T-R-T. And there's less variables, so it's a little bit easier. Our future value is going to be 7,700. Present value we've got is 5,300. E is E. R we don't know. Our time is 19 years, so we're going to say 19R. Rather than the R19 is 19R. And our first step is the same. We're going to divide. Get the R there. Divide as often as you can. Divide. And again, just cancel out the zeros, make it easier. 77 over 53 equals e to the 19r. Now, what do we do from this point? The 19th root. Yeah, you went natural on this one. Anytime you have an e, then the variables in the exponents, 19th root will mark because we've got an r up there as well. The way we undo this is take the natural log of both sides. Because natural log of e cancel, and that brings the 19r down. So we have natural log of 77 over 53 equals 19r. And then we just divide by 19. So this one is 0. And then we'll just type that in. Natural log of 77 over 53. Close parentheses divided by 19. We get our rate move it over 2 places, so that's 1.965%. Just round this to the nearest 10th of a percent. So 10th is going to be this place here, 9. Look next to it to 6, so we're up. So that's not up to 2%. 2.2. So pretty low, right? Even 2% you can grow by 1,000, but inflation will probably be higher than that in the long term, probably over. So we won't actually really gain money. Better than nothing, I guess. So if you just got money sitting in the bank, you're actually kind of losing money, especially right now with inflation like this. You still want to have some money in savings. Not that you should save